Developing software gives you tremendous freedom to create something in your own way. This is true for almost every language. But that freedom means there are good ways and not so good ways to do the same task. A developer, over the course of their career, will face different problems with similar solutions and will naturally adopt patterns. Sometimes they know they're using a pattern. Other times they are using patterns without even realizing it. Patterns are not libraries or classes. They are concepts, reusable solutions to common programming problems, tested and optimized for specific use cases. Because they are concepts, not code, they have to be implemented in your specific language. Every pattern has advantages and disadvantages, and choosing the wrong pattern for a problem can cause significant headaches. Patterns matter for performance in two ways. Some patterns directly increase performance. Others increase it indirectly by enabling an architecture that can scale. Creating high-performance applications involves knowing every bit of running code and understanding the patterns used across your application. Some patterns are introduced deliberately because of their specific benefits. Others appear unintentionally as the codebase grows. Patterns can speed up the development process because they provide well-tested and well-proven development paradigms. Reusing patterns helps prevent issues and improves code readability between developers who are familiar with them. But patterns come with a trade-off. Sometimes, in order to achieve flexibility, a pattern introduces a new level of indirection in the code, which may reduce performance. You have to know when to introduce a pattern and when that introduction will hurt the very performance metric you're targeting. Because of the structure and API model of Node.js, some patterns are more natural and biased toward the platform. The most obvious are the event-driven pattern and the event stream pattern. These aren't enforced by Node.js, but they're so strongly ingrained in the core API that you'll be forced to use them in parts of your application. It's better to understand how they work together, and how you can benefit from them. Using the core API, you can access the file system in two ways. You can read a file with a single method and a callback. Or you can request a read stream and then check for data and end events, or pipe the stream to somewhere else. The second approach is very useful when you don't want to look at the file and just want to serve it to a client. This stream-based architecture was designed to work for core modules like HTTP and NET. When listening for client connections, you listen for a connection event, and then listen for data and end events for each connection. Never ignore error events, they trigger exceptions if not handled and will force your application to stop. Events are the core feature of the Node.js platform. Streams are extensions of event emitters. In the most basic form, a stream is a process of emitting data events with content from some kind of buffer. Events, streams, and buffers together make a very good example of an event-driven architecture, a pattern that fits JavaScript beautifully. Buffers are objects you use when manipulating data that might get broken with string encoding. They're used by the platform to read files and write data to sockets. Many string manipulation functions are available for buffers. The mental model: streams are pipes, buffers are the containers moving through those pipes. Knowing good patterns is important. Knowing anti-patterns is equally important. An anti-pattern is a solution to a recurring problem that is both ineffective and counterproductive. Anti-patterns are not obscure mistakes, they're common errors seen by the majority of mature developers as strategies you should never use. Here are the most common anti-patterns in Node.js development. The first is repeating yourself. Don't repeat excessive parts of the code. Step back, look at the big picture, and refactor it. Some developers treat refactoring as an increase in complexity, it's actually the opposite. If you're worried about readability, add a brief comment. But duplication is technical debt that compounds over time. The second is the golden hammer or silver bullet. In the Node.js ecosystem, thanks to NPM, there are thousands of modules available. Don't reinvent the wheel. Invest your time in using the most common modules for your needs. Building a custom solution where a well-tested module exists is almost always slower and buggier. The third is coding by exception. Your code should handle the most common types of errors cleanly. Avoid handling every possible edge case, handle the common ones and default to a general error handler. Record errors for analysis, but don't build your entire error handling around exception catching, it will increase code maintenance overhead. The fourth is programming by accident. Don't program by trial and error. Success by trial and error is pure luck. Code that works by accident may work in the cases you tested but have erroneous behavior in unplanned situations you never tested. Understand why your code works, not just that it works.